Alright, time for another DraftPhysics.com video presentation. So, a partial, beginning to the lever experiment. This part just trying to get one side of the lever to convey the energy to the other side. Maybe I'll just draw that quickly. Alright, the simple challenge is to see how well a lever converts energy. Now, I've made the argument that it does this thing pretty good of changing a big M and a small v into a big V and a small m, and that's basically what it does. It just converts momentums. So you can take something as a big mass, put in the right place, and convert the energy into something else. Now, the real experiment is to put a half mass twice the distance and see if you can get all the energy from one object into the other object. And it's basically, you're basically doing 5-ton train going 10 miles an hour and converting it into a 10-ton train going 5 miles an hour, or vice versa. The important one would be the vice versa. If you can do the vice versa, you can basically prove that the kinetic energy theory isn't mean anything, because something with half the energy can create something with twice the energy. So if you can put a 2 mass in at 1 velocity and get a 1 mass at 2 velocity, you basically, in my opinion, have provided a pretty decisive proof that the 1/2 mv squared theory can't be true. So anyway, that's the objective. Now, before you can get to that stage, you first have to find out how much energy you're losing to the lever system. So the objective is to first just do 1 mass against 1 mass, or however you want to look at it. That would be a velocity there, so my mistake anyway. And so this first experiment is just seeing if I can get this energy to result in an output that's something like 80 or 90% of what goes in. So if you can conserve 80 or 90%, then you have a chance of getting a decent answer when you go further down the lever with different objects. So that's my objective doing these experiments, to see how efficiently I can put energy in here and how much of it I can get back out here. And so far, not terrible. I mean, I think it is somewhere around 70 maybe. Maybe a little better than that. So we'll see. I haven't really inspected any of this yet, so I just uploaded these to the computer, and haven't really processed them or frame rated them or any of that kind of stuff. So there's 4 videos, and so the first one is this video is a hollow steel rod, very light. The next one is one with a strobe light to help maybe do frame rates, and the third one is a solid steel rod, and then the fourth one is a fiberglass rod. So just for the sake of trying what I had laying around, I fiddled with the fulcrum a little bit here and there. What's basically, there's a steel file, okay, that creates a pivot point, and I've made it even narrower now by putting a little tiny steel, a thin piece of steel, I don't know how to describe it, I mean, like a really thin piece of steel running as the fulcrum, so the hollow steel rod is resting against a little steel rod. Now in this one, it's not, it's resting against a metal file. So I think it improved it a little bit by including the other thing, but I haven't got video of that yet. I haven't redone it that way yet. So anyway, so this is, I mean, I see opportunities here to do the clay experiments, do all kinds of different experiments. So, once you start doing this stuff and messing with it, there are other things you can do. So we'll see. So I might as well play some of this while I'm talking. That would have been the smart thing to do. Kind of basic. I got to come up with better ways so my hand doesn't get in the way, or yesterday my head got in the way so you couldn't even see anything. But it doesn't look terrible. So you can say that this is the distance it's falling from, and you're trying to get the same distance out of the other side if possible. I mean, that would be perfect. So we'll see how Yeah, see, it wasn't bad. I mean, it was here-ish, which was like 70%. Now, the paper is crooked, so that doesn't help any. So I do straighten that out in the other videos. So it's not bad, is the point. It's, not horrible. But I haven't checked the actual velocities. So again, I could mark a position here. Let's see if there's some way I could do that with my mouse, but I could. If this is spacebar should work, right? So I'll leave the mouse there. Yeah, there we go. Okay, so that's as high as it went. So you can see it is a bit lower. It's a little short. So the question is how short, and obviously the further, I mean, the shortness means a little bit more than what it looks like, because this is the easy traveling distance and this is the harder one. This is the going up in gravity part. So 1 inch here really matters, where it doesn't matter so much down in this lower part, blah blah blah. But you do get some continued action, even though things start turning in bad directions. So there's lots to say. Yeah, this is interesting. It's good. I like it. It's not completely it's not bad. Now notice here too, there are no bounces. Okay, this mass comes in, it doesn't bounce at all. Pretty much, I don't see any bounces. I didn't notice any when I was making the video, so I guess I shouldn't say there aren't any because I haven't seen it yet. But I didn't notice anything significant. So unlike certain people's predictions, it's nothing like their prediction. Their model must be completely wrong because they made wrong predictions about what would happen. All right. So you can see maybe it bounced a ½ inch or something, but it wasn't much. And this is, it's pretty good at airtime here. So it's, like I said, it's not bad. I think I can make it better. So look at, see, it keeps going a little bit, so not bad. All right, so you are viewing this from down. So these are pieces of steel. This is like 7 centimeters of ½ inch steel, solid steel. So I don't know what the weights are. I'll eventually weigh them, but who cares? They're the same size, so they're this approximately the same weight. The markings on the lever aren't perfect. I'm just trying to get close to the same distance. I'm not trying to be as super accurate. I'll work on all that. This is a sledgehammer, and the camera is about 3 feet high, on the handle of the sledgehammer looking down. So at least there should be sort of an even view. So these lines should be the same thickness and all that kind of stuff. So all of that's pretty good. There's wire, and then it's fishing line going the rest of the way up on the base. And so I think that's probably enough of that information. And my wire disconnected here, so I'll have to reconnect that. I'll probably do take. No, I don't bother fixing it yet. So all in all, not terrible. Sort of working. Close. The speed looks close. I mean, when you look at it, it looks like it's going the same speed. Close to it. But I mean, I know it's not. But it looks pretty close. So that's all good. Now the problem is, the further out you go on the lever, the more you got to worry about it bending. Different things that are going to screw up the experiment. So you really have to start with having pretty good conservation, because the whole argument gets very subtle once you get into this whole 1.4 thing. And if you're losing 20%, then 1.6 can look like it's pretty close to 1.4. That kind of stuff becomes dangerous. So you really want it to be more decisive and clear, if possible. So we might as well play this one through. I think this is the last. Oh no, it's only. Yeah, so it's only 2 minutes of a 5-minute video. Wow. I didn't realize it was that long. All right, well, so maybe we'll move on to the next one. I believe I put my finger on it. There it is. See, I'm putting my finger on it now. And that seems, I think it does help to make sure that the lever doesn't, the fulcrum doesn't bounce. See, that looked pretty good. So I think it helps to make sure the fulcrum doesn't have any jitter in it at all. That, you know, it really has to just do the moving for the purpose of just the one movement, you know, not doing any bouncing or consuming of the energy. Alright, that one they hit crooked, so of course it was a little bit less impressive. Alright, so let's do the strobe light one, I think is next. Don't need the gardeners next door. Yeah, so I don't know. You know, it's a little bit annoying, so be prepared for that. But I think it might help in terms of frame rates. So that's the reason why I did it. So I think it will help. Yeah, so not bad. I liked it. Pretty good. So I don't think I changed anything else. I don't have the little steel piece in front of the fulcrum on this one yet. So, and I think that does help. I think. Alright, so really, you know, it looks like at least 80%, right? I mean, it looks pretty close to 80, so got to do a little better than that, maybe. Hopefully. Watch one more, and we'll move on. And such. The video should be good enough to get reasonable frames out of it. Yeah, the lighting just isn't perfect. But you can sort of see there really is no bounce. The first thing hits, it does not bounce. It does not reflect. That don't happen. And it doesn't continue straight through either. Alright, that was a bad hit. Miss hits don't count. Alright. So this should be... Yeah, this one's the solid steel bar. Really annoying. Okay, yard people. Eek. Alright, get rid of all the sound. Leaf blowers. Ugh. And it really doesn't look that good to me. Okay, so the solid steel bar just didn't, you know. Let's mark it up here. Okay, and then hit this bit. Oh, too late. Okay, next time. Try it once more, see if I can mark it properly. And then I'm trying to hold it with my finger too, which is not easily done. Okay, so we'll put the mouse here. And that's about where I left it when I let go of it. And we'll see if the other side can get close to that high. No, way short. Yeah, so yeah, not too good. So steel bar, not too impressive. Solid steel. That was a little better, so frankly I'm going to try to make better things for it to sit on when it's sitting on the bar, like to make sure it is making solid contact. So I might try some bakeable clay or some other method to create a foundation to hit with, you know, that's more encompassing. But we'll see if that, you know, that might just get in the way. Alright, video number 3 is fiberglass. So this was better than I thought it would be, frankly. I think. I mean, I can only go by my memory. Okay, so I'll put my mouse here. It looked pretty good when I made the video. So let's see what happens. Yeah, no, not so much. Still, you know, an inch short, which is pretty, you know, it's a big inch. I'd be better than that. Alright, so not as good as my brain remembered. I'll play another one or two. Alright, mark that about here. Oops, stay. Okay. I did straighten the paper so you can see it's a little better. Yeah, well, I blew that. But yeah, it's still short. Okay, so but it was better, like 90 or 80 instead of 70. Yeah, I'll check another one or two and call it a day. This video. Right. So that hit good, and that's it's not terrible, but yeah, not quite good enough. See these little bounces. You can see there's quite a lot of action in the little bounces. So let's see with the finger on it. Alright, so this ought to be interesting. Alright, see how it goes. Yeah, not bad. So I think it really does help to, I mean, like I said, I have rubber bands around the thing and holding it, but it's like I think it still does jitter. And you got to take the jitter out of it. Hey, look at those little bounces, seem pretty good. Yeah. But yeah, obviously it does run out of energy quickly. So far from ideal and perfect and great and fantastic, but as a partial statement, it's partially there. So enough and such. So that's the progress. Like I said, I think I will be doing other experiments also, and obviously I have to start doing some frame rate counting, which I really don't want to do, and all that kind of crap, but we'll see how that goes. Just data collecting first and seeing if I can get it a little better before I try the double mass to half mass experiment. Alright, so I did see that physicist Michael has a response to my previous comment that's just amazing. So I guess I'll make that video. But yeah, I mean, they keep arguing as if these experiments are already done somewhere, and like we already have all this proof, and we all know that it takes 9 times the fuel to go 3 times as fast, and it's been done so many times that we all know it. When no, none of that's happened. It's just so bad for people with such a poorly evidenced theory to argue from such an arrogant position. It's just, I mean, it's a kind of evil, frankly. But anyway, till the next time and such, and so forth and whatnot. So, links below to the 4 videos if you wish to see the raw content.